So, good afternoon, everyone. And this is lecture number 4 in motion in 1D. And we are going to deal with the next quantity, that is acceleration. Before going on to the next quantity, in the last class, we had dealt with average velocities and instantaneous velocities. Yes or no?
Yes, sir.
And we had seen some questions of integration, differentiation as well. We had seen how to calculate the instantaneous velocity. Just put the value of time. To find the average velocity, you have to find the total displacement and divide it by the total time. Yes or no?
Yes, sir.
That takes us to the next topic, and the next topic is definitely acceleration. Yeah. See, what is acceleration then? See, when the particle is moving with a uniform velocity, his velocity will not change in magnitude, it will not change in direction. But what type of motion will be motion of uniform velocity? If a particle is moving with uniform velocity, what type of motion would be there? What type of motion would it perform if it is moving with a uniform velocity? Will it be a, yes?
Rectilinear motion.
It will be motion in one dimension or rectilinear, or it always keep on moving in a straight line, because if it turns, that does not remain a question of or a case of uniform velocity. We understand this?
Yes,
So,
sir.
Motion with uniform velocity implies that the motion has to be in a straight line. Having said that, let us now come to the point where the velocity is going to change. And how can the velocity change? In what aspects can the velocity change? Velocity can change in number one. It can change in what?
Direction.
It can change in direction. Number two.
Magnitude.
Or case number three, it can change in
Both, sir.
Both magnitude and direction. And what changes velocity is the next character in our story, and that is known as acceleration. Do we understand this?
Yes, sir.
Acceleration denoted by the letter A. It's a vector, so I put a symbol of vector. Now, as soon as acceleration comes, we need to define it. What is acceleration? It is the rate of
change of velocity.
It is the rate of change of velocity with what?
With time.
It is the rate of change of velocity with time. Yes. If the velocity of the particle is changing with time, we say that the particle is accelerated. What type of quantity is acceleration?
Vector quantity.
As soon as we understand that this is a vector, we must always think about two things. What are those two things?
Magnitude and direction.
One is the magnitude, the other one is direction. Yes or no? We all understand this?
Yes, sir.
Okay. Now, what will be the unit of acceleration and what would be the dimension?
Meter per second square.
Meter per second square is the unit, and the dimension is L raised to the power
-2.
We all understand this, yes or no?
Yes, sir.
Now, as I told you, even in the case of non-uniform velocity, that the velocity can change in magnitude, the velocity can change in direction, or velocity can change in
magnitude and direction.
And therefore, who has to do this job of changing velocity? This job of changing velocity has to be done by?
Acceleration.
This job of changing velocity has to be done by? Acceleration. And therefore, this acceleration can do a variety of things. What are the things that this acceleration can do? So we will discuss them one by one. It is written in a tabular form of a tablet, or not a tablet, form of a table right in front of you. Now, the simplest case that we encounter in motion in one dimension, when the particle is just moving on a single line, that the velocity only changes in magnitude. That is the simplest case that we understand, where the velocity only changes in magnitude. Now, if the velocity changes in magnitude, it will either increase in magnitude or it will decrease in magnitude. Yes or no?
Yes, sir.
In that case, acceleration has to be parallel in the same direction, or it can be
Anti-parallel.
anti-parallel in the opposite direction. So if I draw velocity like this, if I write velocity like this, v vector, then the acceleration, if it is in this direction, what will it do? When acceleration is parallel to velocity, what will it do to the velocity? In this case, what will happen is velocity of the particle will increase in magnitude. Do we understand this?
Yes, sir.
When velocity and acceleration are in the same direction, velocity of the particle will increase with
Increase.
time. That is what sometimes people call as positive acceleration. So whenever someone talks about positive acceleration, remember acceleration is a vector quantity. When someone talks about positive acceleration, what he means is this acceleration is positive. That actually refers to, this positive sign refers to what? It always refers to the direction of vector.
Direction.
In this case, this positive sign means that the direction of acceleration is same as the direction of velocity. Do we understand this?
Yes, sir.
In this case, velocity is going to increase. We call it accelerated motion. Can I have raised hand from everyone that we understand this?
Yes, sir.
Do I see a new boy in the class? Is there a new boy in the class?
Yes, sir.
First class?
No, sir. It's I have already listened on online.
Okay. Okay. So you are able to understand what is going on in the class, bacha?
Yes, sir.
Okay. Now, what will happen if velocity is opposite? Oh, sorry. Acceleration is opposite to velocity. So, for example, let me just change the direction of velocity. Let me say that the velocity is like this, and my acceleration is opposite to this, like this. In that case, what will happen? And janbooch ke, knowingly, I have drawn the velocity at an angle not along positive x or negative x. If the if velocity is in this direction and acceleration is in this direction, then what will happen, my dear
It
friends?
would be negative, sir.
Velocity
The
will
velocity decreases.
velocity will decrease, and this type of acceleration in normal language, in the language of the books, is known as negative acceleration. People also call it deceleration. Do we understand this?
Yes, sir.
So all these terms, deceleration, it comes from this negative sign. This negative sign just tells us, just indicates that the direction of acceleration is not the same as the direction of velocity. In fact, it is exactly opposite. In that case, velocity is going to decrease. That acceleration in books is known as deceleration. Remember, from what I understand, the term deceleration is not defined. There is only one definition, and that definition is for acceleration. But books may call this negative acceleration as deceleration. Do we understand this?
Yes, sir.
This is all about acceleration being parallel or acceleration being opposite to the direction of velocity. It will change the magnitude of velocity, and magnitude of velocity is speed. Do we understand this?
Yes, sir.
So I can also write that in this case, the speed of the body will change. The speed of the body will change. Do we understand this? Yes or no? No, yes.
Yes, sir.
Then, this is not the only case. Acceleration may not be always parallel or anti-parallel to velocity. This will only happen. This particular case, the yellow case, will only happen when we are dealing with motion in one dimension. Do we understand this?
Yes, sir.
So whatever type of acceleration we are going to deal in motion in 1D, it will always be either parallel to velocity or it will be opposite to velocity, so that it does not change the direction of motion. It will change the direction of motion. If the particle is moving straight, it can go back. In that sense, it can change the direction. Otherwise, it cannot make the body to turn right or left or in any other direction. That is what motion in 1D implies. But there can be, this is not the only possible direction of acceleration. In fact, there are infinite directions which are possible. What will happen if how can I change only the direction of velocity of the particle? How can I change only the direction of velocity of the particle? Now, if the acceleration is parallel or anti-parallel, I can change the magnitude of velocity. How can I change only the direction of the velocity?
Uniform circular motion.
Yes, bacha?
Uniform circular motion.
Array, how will I change it? How will I change only the direction of velocity and not the magnitude of velocity? How can I change it? How can I change only the direction of velocity and not the magnitude?
When the direction of acceleration is perpendicular to velocity.
That is absolutely correct. It is also written here when the acceleration is perpendicular to velocity. Say, for example, I take the velocity like this. And if my acceleration is like this, exactly perpendicular to the velocity, this acceleration, my dear friends, is not going to change the magnitude of velocity. This acceleration is going to change the direction of velocity. So if we want to change only the direction of velocity, in this case, tell me, in which direction is the body going to turn? If the acceleration is like this, it will turn in the same direction because it will change the direction of velocity in the same direction. Do we understand this?
Yes, sir.
This type of acceleration which only changes the direction of velocity, this type of acceleration is also known as normal acceleration. You understand why it is called normal acceleration?
Yes, sir.
Why it is normal?
Because
Why it is called as normal acceleration?
it is just changing the direction.
Because it is called normal acceleration because it is normal means perpendicular. It is perpendicular to velocity. It is perpendicular to velocity and therefore it is known as normal acceleration. Some people also call it radial acceleration. Some people also call it centripetal acceleration. Have you heard these terms?
Yes, sir.
All these accelerations are nothing but they are perpendicular to the velocity. They can only change the direction of motion. They can only change the direction of velocity. These accelerations or this acceleration is known as normal acceleration. If I have told you what is this acceleration, then I have to also tell you what is the first acceleration, which was changing the magnitude of velocity. Do you know the name of that acceleration? That acceleration is known as tangential acceleration. Tangential acceleration. This type of acceleration which changes the magnitude of velocity is known as tangential acceleration, written by a t. T standing for tangential. This can be written as an for normal,
Normal acceleration.
ar for radial, or ac for centripetal. I hope everyone is noting down.
Yes, sir.
This acceleration is known as centripetal, which is changing the direction of velocity. The acceleration which changes the magnitude of velocity is known as tangential acceleration. Do we understand this?
Yes, sir.
But these are only two cases of the infinite number of cases that are possible. How can now I change? Now, what type of motion will be the green one? The yellow one, when direction of acceleration was opposite or in the same direction, it was motion in 1D.
1D.
What type of motion will this acceleration give rise to? When the acceleration is perpendicular to the velocity, what type of motion will the particle follow?
Motion.
Then can be motion in 2D or motion in 3D, depending on how they are related to each other. Do we understand this?
Yes, sir.
Now the question is, how can I change both? How can I change both? Both means How can I change both magnitude and direction of velocity? Tell me. How can I change both? Please do not just look at the board, beta. Please write. Please make your notes. Right now, it may look very simple, but at the end of the day, you are going to not remember all of this. Please make your notes. Your notes is the only thing that is going to save you, not anything else. Yes. How can I change both?
If
Beta.
acceleration is perpendicular to velocity and the other is parallel to the velocity.
See, acceleration can only be in one direction. I cannot have acceleration in two directions. Yes or no? I can have only acceleration in one direction. If my velocity is like this, v, if my acceleration is like this at an angle, then what will happen? If my acceleration is at an angle, I can resolve this acceleration into two components. One would be AT and one would be AN. So now this is going to do both the tasks. This acceleration, which is at an angle with the velocity, this angle is not 0, because if it is 0, it becomes tangential acceleration. This angle is not 90, because if it is 90, then it becomes normal acceleration. This is somewhere between 0 and 90. This acceleration is going to change both the magnitude as well as the direction of velocity. I can write this acceleration A vector as A tangential vector plus A normal vector. Do we understand this?
Yes, sir.
I can also find the magnitude of this acceleration. It consists of two components. One is the tangential component, the other one is the normal component. So it will be, the magnitude will be equal to under root of
A tangential square plus
A tangential square plus A normal square. I can also find the value of this tan theta with the tangential axis. It will be equal to the normal component divided by the tangential component. Do we understand this?
Yes, sir.
This is all about acceleration, the beginning of acceleration. What does acceleration do? Well, the answer is acceleration changes velocity. It can change only the magnitude of velocity, tangential acceleration. It can change only the direction of velocity, normal acceleration. It can do both. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay, sir, I'll give you 2 minutes to note this entire thing down. Once you are done.
Sir, it's done, sir.
Oh, you have become so fast. Well done.
Thank you.
Well done. You have picked up speed, and that is good. Everyone has done.
Yes, sir.
Well done. Then I move to the next thing. And what will be the next thing? We have understood what acceleration does. We have understood what is acceleration. What should be the next heading? The next heading that I can write is types of acceleration. Yes. Now, when I say types of acceleration, you can also call normal acceleration as a type of acceleration. You can also call tangential acceleration as a type of acceleration. But I hope we have already understood this. So what is the first type of acceleration that we will understand? Yes?
Uniform acceleration.
Uniform acceleration. Uniform acceleration. Now, the other name for uniform acceleration would be
constant acceleration.
Constant acceleration, or acceleration remains
same.
So that is what I will understand. If the acceleration of the body remains same, acceleration remains constant or same. When I say it remains constant or it remains same, it must remain constant in
magnitude and direction.
Remember, whenever we are talking about vectors and we say the vector is Constant. It has to be constant in magnitude as well as in direction. Do we understand this? Yes or no?
Yes, sir.
Okay. Now, as soon as we hear this term constant acceleration, one thing comes to our mind automatically, that if the acceleration is constant, see, I told you, when the velocity is constant, when the velocity is uniform, what type of motion the body has? The motion is always a
1D.
1D or straight line motion. If I ask you, if the acceleration of the body is constant, what type of motion the body will have? Remember, I've changed the terms. The first thing that I told you was, if the velocity of the particle is constant or the velocity of the particle is uniform, then the motion is 1D or straight line. What happens if the acceleration of the particle is constant or uniform? What type of motion will the particle have? Will it be straight line? Will it be motion in 2D or anything else? What do you think? What type of motion particle will have if the acceleration is constant?
2D, sir.
Yes, beta?
Motion in 2D.
Say.
Motion in 2D, sir.
Motion would be?
In 2-dimensional.
Well, you are partly correct and partly not correct. The motion can be a straight line motion. The motion can also be a 2D motion or a projectile motion. If the particle is at rest, and then you give it constant acceleration, in that case, the motion would be straight line. If the particle is already moving and then you give it acceleration at some other angle, then the motion will be motion in 2 dimensions. So if a particle has constant acceleration, its motion can be 1D, its motion can also be 2D. In what cases will its motion be 1D? If it starts from rest, or if the direction of acceleration is parallel or opposite to the direction of velocity. In any other case, if it is already moving and the direction of acceleration is not the same, it would be motion in 2 or 3 dimensions. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
Everyone has written this?
1 second, sir. Done, sir.
The first type of acceleration, if it is uniform acceleration, what will be the second type of acceleration look like? And it would be non-uniform. We can have another term for non-uniform. What will be the another term for non-uniform?
Variable acceleration.
It would be variable acceleration. In this case, a body is said to be moving with non-uniform or variable acceleration if the magnitude or the direction or both change during motion with time. So if you have an acceleration which changes in magnitude, or an acceleration which changes in direction, or an acceleration which changes in both, or any one of them, then the particle is said to be moving with
Non-uniform.
non-uniform acceleration. Do we understand this?
Yes, sir.
We have done uniform acceleration, we have done non-uniform acceleration. I'll give you a minute to note it down.
Yes, sir. Done, sir.
If one acceleration is uniform, the other one is non-uniform, what will be the third type of acceleration?
Average acceleration.
Yes, if you understand how we are doing things, everything just follows one pattern. Average acceleration. And how I'm going to write average acceleration? I will write acceleration with a vector sign and I'll put it inside a box. This box defines that average thing. Do we understand this? Yes or no?
Yes, sir.
Now, can you tell me, Bacha, what would be this average acceleration?
Total velocity by total time.
Total velocity by total time. Think again.
Change in velocity by total time.
Total, or I can just, instead of writing the word
Change in
total, I can write
velocity.
change in velocity divided by total time. Do we understand this? If the
Sir.
velocity of the particle changes, how much it has changed divided by in how much time it has changed. If I have to write average acceleration, I will say delta V divided by delta T. And I've already told you the meaning of this delta. This delta means change. Do we understand this?
Yes, sir.
Change in velocity divided by total time. And now I can write it as Vf. Whenever I say change, it is final minus initial, yes or no?
Yes, sir.
Vf minus Vi divided by T, or you can say V minus U. Normally you use V for final velocity and U for initial velocity. So you can write it as V minus U divided by T. Do we understand this?
Yes, sir.
Again, remember, whenever we are talking about average, average is always calculated over an interval of time.
Interval
Yes or
of
no?
time. Yes, sir.
From this time to that time, from here to there, and so on. Yes or no? No, yes.
Yes, sir.
That was our friend average acceleration. Now, if average acceleration has come and that is calculated over an interval of time, what is the fourth type of acceleration that should come?
Instantaneous acceleration.
Well, there must be any acceleration that could be calculated at any given instant. That is known as your instantaneous acceleration. And instantaneous acceleration is denoted by a vector. Now, as soon as I write this a vector, this should ring a bell. And we must understand that whenever we are talking about, or generally we are using the term acceleration. What is your acceleration? We are referring to which type of acceleration? We are referring to the instantaneous value of acceleration. Do we understand this? Yes or no?
Yes, sir.
It is similar to saying, what is your speed? When I ask you that, what is your speed? I mean, what is your speed right now? Instantaneous speed. When I ask you, what is your velocity? I'm asking about your instantaneous velocity right now. When I'm talking about acceleration and I ask you, what is your acceleration? I'm talking about your instantaneous acceleration. Yes or no? No, yes.
Yes, sir.
So we know this. This will be rate of change of v vector velocity with time. Yes or no?
Yes, sir.
Or I can also write it as acceleration at
At any instant of time.
any instant. Then comes the formula for this. dv by dt. Do we understand this? Yes or no? No, yes.
Yes, sir.
Or I can also write it as d by dt of v is dr by dt. Yes or no? Is the second derivative of r.
Yes, sir.
So I can also write it as d square r by dt. Do we understand? It is the second derivative of position vector with time.
Done, sir.
Done, sir? Now remember an important point. If your acceleration, or I should not use this because then it will get confused. If your acceleration is uniform, same, constant, then what can you say about average acceleration and instantaneous acceleration? Are they going to be same or are they going to be different?
They will be same, sir.
They would be same. So your average acceleration becomes your instantaneous acceleration. And this is what you write as v minus u by t. But again, this is only valid when the acceleration is
Uniform.
That is what you have to remember. Whenever you have written a as v minus u by t, you've actually not written the value of a. You've written the value of average acceleration and you assume that the acceleration is constant. Do we understand this?
Yes, sir.
From this dabba, you actually derive your first equation of motion for uniform acceleration. And what is that equation that you derive from here? V minus u is equal to at. Do we understand this?
Yes, sir.
But again, this acceleration is only valid when the acceleration is
Uniform.
this equation is only valid when the acceleration is uniform. But there is one equation which is always valid. But there is one equation which is always valid. And which equation is always valid? Average acceleration is always equal to Do we understand this?
Yes, sir.
Or is it getting too confusing for you to understand? This equation is always valid because this is the definition of average acceleration. But v minus u is equal to at is only valid when the acceleration is constant. We have got this, yes or no?
Yes, sir.
Everyone got this?
Done, sir.
Everyone has written this.
Yes, sir.
Since here we are understanding acceleration, we can write some important notes. Important notes or important points. And I hope these things are self-explanatory. So I'll just put them with a description as well. Important point number one. Important point number one. Now, sometimes we get confused with this. We look at the direction of acceleration and we assume that wherever is the direction of acceleration, the velocity will be in the same direction and the particle will be moving in the same direction. But you must understand that for a moving body, there is no relation between the direction of velocity and the direction of acceleration. You can look at this circular motion. In this circular motion, the direction of velocity is along the tangent, but the direction of acceleration is along the normal. You understand this, yes or no?
Yes, sir.
And in this case, this angle is always 90 degrees. This is uniform circular motion. Velocity and acceleration are always perpendicular. So there is no relation between velocity and acceleration ka direction. Do we understand this?
Yes, sir.
This is your parabolic motion. And here you can see velocity is keeping on changing its direction. Yes or no?
Yes, sir.
But the acceleration is always constant and it is
Constant.
always directed downwards. That means if the acceleration is constant, particle may not move in a straight line, it can move in a parabola. it can move in any other path as well. Do we understand this?
Yes, sir.
Anyone has any doubts on this?
No, sir.
One more point which I would like to state again. I hope you have noted this down. You don't have to draw the diagram. It is
Done,
just
sir.
for you to understand, right?
Yes, sir.
One more important note comes your way now. And remember this positive or negative acceleration. When anyone talks about positive or negative acceleration, they're
It
only
refers to
referring to its direction. Negative acceleration is sometimes known as deceleration. Positive acceleration means that the velocity is increasing with time. Zero acceleration means velocity is uniform or constant. Negative acceleration means retardation, which means velocity is decreasing with time. Do we understand this? Yes or no? No,
Yes.
yes. Now can you move on to some question and answers?
Yes, sir.
The first question comes, and it is a previous year question, way back. Let's see if we can do justice to this one. And here it comes. Remember, whenever a question comes, if this question has come in the previous IITs or IIT-JEE or JEE, it has to be a simple question. Up till now, only one question, I think, in physics that was asked, one or two maybe, which were difficult, so-called difficult. This is the one somewhere near to the year when I was born in the year 1979. This is 1982. A particle is moving eastwards with a velocity of 5 meters per second. In 10 seconds, the velocity changes to 5 meters per second northwards. What is the average acceleration? What is the average acceleration? I'll give you 2 minutes to solve this. Shall I help you out or you want to do it on your own? Do you want more time? Yes or no? No, yes. Shall I do it? Not getting any satisfactory answer.
No, sir. Not getting the answer.
Okay. Not getting the answer. I leave this question now. Give you another one. Probably we can start with that one first. Let me see if you can do this one. Remember, we only have to understand or remember. We only need to understand and remember the basic definition. If we understand and remember the basic definition, we should be able to solve any question. Let me put another question. Can you solve this one? The question comes on your screen now. The velocity of a particle is given as 10 plus 2t square meter per second. This is a question from your sheet that I've sent you. Question number 31 from your sheet. Did you get the sheet? This is question number 31. Where is the sheet? Show it to me.
Yes, sir.
See, everything is kept in the box. Take it out. Take them 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 out. Yes. Question number 31. Move 2 or 3 pages down the line. You will find question number 31. Find it. Do it. So now I will give you question from this sheet only so that we can save some time in writing the question. Yes, bacha. The velocity of the particle is. How many of you are trying the question from the sheets? From the sheet. Only 1, 2, 3, 4. Okay. I can assure you, if you can only do the question from the sheet, it's more than enough that you'll require. It's more than enough. But I would wish that you can do more questions.
Sir, the answer is B.
The answer is D. I don't know the answer. So
4 meter per second, sir. B.
So the answers key is also there in the sheet, no? Check it. I think it would be correct. The answer matches your answer key. Answer key is there, yes or no? End of the sheet, answer key is there. What's the answer from the answer key? Matching?
No, sir.
No. Matching?
Not
Yes,
matching.
sir. Then congratulations, sir. You are correct, sir. Now remember how we got to do this. I have to find, remember the definition, I have to find the average acceleration from 2 to 5 seconds. From 2 to 5 seconds. So I first write the formula for average acceleration from 2 to 5. So I write 2 to 5 here. So the final velocity is at 5 seconds. So I write V5 minus velocity at 2 seconds, final minus initial, divided by how much is the time? 5 minus 2. Yes or no? You just have to find the velocity at 5 seconds. How will I find the velocity at 5 seconds? In this, put the value of time as 5 seconds. Do we understand this? How do I find the velocity at 2 seconds? In this equation, put the time as 2 seconds. And then you divide it by the total time, 5 minus 2. Can you now tell me, bacha, what is the velocity at 5 seconds? Yes, my dear friends. No one? What is the velocity at 5 seconds? Just put the value of t as 5. T square is 25. 25 into 2 is 50. 50 plus 10 is 60. Yes or no? So velocity at 5 seconds is 60. Do we get this? 60 minus, now put the value of time as 2. 2 square is 4. 4 into 2 is 8. 8 plus 10 is 18. So minus 18 divided by 3. 60 minus 18 is how much?
42, sir.
42. 42 divided by 3 is how much?
14.
14. And that is your answer, my dear friends. And that is how you get the answer. Do we understand this? Yes or no? How many of you got the answer? No one got the answer? No one got the answer?
Everyone got the answer, sir.
Got it, now?
Sir.
Okay. Let us solve this question then. I think this is again from your sheet. This is question number, can't see which one. 24 from the sheet. Question number 21 from 24 from the sheet. The displacement of a particle is given by x is equal to 2t squared plus t plus 5. What is the acceleration? Which acceleration is he talking about? Acceleration is 2 seconds. Which acceleration is he talking about? Which acceleration is he talking about, my dear friends?
Instantaneous acceleration.
He is talking about instantaneous acceleration. That is correct. In first question, we solved it for average acceleration. Now we are solving it for instantaneous acceleration. Can you do it for me?
Answer is A, sir.
Answer is A, sir. 4 meter per second square, sir. Okay, sir. How do you do it? You first write x, which is the position of the particle or the displacement of the particle they have said. You differentiate it once. What will you get? You will get the velocity. Yes or no? Yes or no? Do we understand this? You differentiate it once more. You will get the acceleration, and acceleration is going to come as 4. What type of motion is this? Is this motion with uniform acceleration or motion with constant acceleration? Tell me, my dear friends. Is this A question, is this an example of uniform acceleration, constant acceleration, variable acceleration, or no acceleration? Tell me. That is how questions are framed. Yes.
It's variable up to 2 seconds.
Acceleration is variable. Where do you see the variable quantity here, beta? Tell me. Acceleration is 4 meter per second square. This is a case of constant acceleration. Do we understand this? Yes or no? Acceleration does not depend on time. It is coming as 4. Therefore, this is an example of constant acceleration. Do we understand this?
Yes, sir.
Raise hands will give me more confidence. Do you understand this?
Yes, sir.
Acceleration is coming as 4. Time is not coming anywhere in acceleration. And therefore, this acceleration is uniform or constant. Can I move on to the next question? Do we understand this? What is happening in the class?
Yes, sir.
Or it's all going above our head saying bye bye, bye bye, we are going, bye bye, I'm going, I'm question and I'm going out. Shall I move on to the next one?
Yes, sir.
The next one is again from the sheet. I think it is question number 25 from the sheet. The velocity of a body depends on time according to the equation. V is equal to 20 plus 0.1 t square. The body is undergoing. 4 options are given. There are 4 options given. And those 4 options are on your screen right now. Uniform acceleration, uniform retardation means negative acceleration, non-uniform acceleration, and zero acceleration.
Non-uniform acceleration, sir.
Non-uniform acceleration. How did you get it, bacha?
It depends on time, sir.
It depends on time, sir. That is what you must understand, sir. So how do you solve this, beta? Acceleration is the derivative of velocity dv by dt. So I differentiate velocity. Derivative of this is 0. So I have 0.2 into t. Yes or no? That's a derivative. Yes or no? And you look very clearly in this acceleration. If you compare it with the previous one, let me again show you the previous one so that things are crystal clear in your head. Look at the first one, the pink one. Look at the second one, the blue one. Do we understand the difference between the two?
Yes, sir.
The first one was 4. 4 is a number, constant. Acceleration was constant. 0.2 t, definitely not a constant. Do we understand this? Yes or no? No, yes.
Yes, sir.
Well done. Can you move on to the next question then?
Yes, sir.
Again, this is taken from your sheet. Since I've got your sheet, I don't want you to waste time. This one, I think this is question number 27 from your sheet. So you can have a look at that question. Question number 27, and then you can tell me the answer. The correct statement from the following is a body having zero velocity, and these are the questions you might get troubled by. These are the questions that are going to come in JEE. Which of the following is the correct statement? A body having zero velocity will not necessarily have zero acceleration. A body having zero velocity will necessarily have zero acceleration. A body having uniform speed can only have uniform acceleration. A body having non-uniform velocity will have zero acceleration.
Option A, sir.
A body having zero velocity will not necessarily have zero acceleration. That means it can have a constant velocity. The acceleration may be 0, but this velocity is 0 beta. Velocity, the particle is not moving at all. Look at all the options that you have. Let us start from the bottom. A body having non-uniform velocity will have 0 acceleration. Is this possible? Non-uniform velocity means it must have acceleration. Yes or no? So this option is definitely wrong. Let us look at the third option. A body having uniform speed can only have uniform acceleration. No, it can have variable acceleration. If you think about the circular motion, uniform circular motion, speed is constant. Acceleration is changing its direction. Therefore, this option is also wrong. So the only competition is between option A and option B. Look at option B. A body having 0 velocity, that means it is not moving at all. Will necessarily have 0 acceleration. Can it have 0 acceleration? Now we have to think about if I throw this body up in sky, motion under gravity, at some point it will come to a rest. Yes or no?
Yes, sir.
At that point, the velocity is 0, but is the acceleration 0?
No, sir.
It still has acceleration, so it can come down, right? So this option is also not possible. Now we come to the last option. A body having 0 velocity will not necessarily have 0 acceleration. So this is the example. It has 0 velocity, it has acceleration, so it can have acceleration. You can also have a particle at rest and you are giving it a push. So it has non-zero acceleration, or if a body is at rest, the velocity is 0 and the acceleration is also 0. So both the things are possible. If the velocity is 0, acceleration can be 0. If the velocity is 0, acceleration may not be 0. Both the cases are possible, and therefore the correct option is
A.
That is how you have to think. Do we understand this?
Yes, sir.
Before winding off this class, I'll give you one more question, and then that question that I gave you will move on to your homework wala part, because I have to also give you question for the homework part. So before moving on, this is the last question for the day. Again, taken from your sheet. This is question number 26, taken from your sheet. And it has 4 options, so I'll put those 4 options also. Let me put them first. Meanwhile, you can have a look at the question and tell me what is the possible answer. So the question and the options are there. The displacement of a body is given to be proportional to the cube of time. Displacement is cube of time, or the position of the particle is cube of time. Sometimes they use the word displacement, which should not be used. The displacement of a particle is given proportional to the cube of time. The magnitude of the acceleration of the body is increasing with time, decreasing with time, constant but not 0, 0. Which is the correct option?
Increasing with time.
And the answer is?
Increasing with time. A.
It is increasing with time. How do you get this? So I write this x is proportional to t cube, or I can write this x as k times t cube. K is a constant, yes or no? I differentiate this x once, dx by dt. When I differentiate this x once, I will get the velocity, yes or no, 3kt square. To find the acceleration, I differentiate this velocity once more. So I will get 6k into t. Now, as soon as I get 6k and multiplied by t, with time, it depends. As time increases, time cannot decrease. As time increases, acceleration is going to increase. So the only option that is correct is option A. Do we understand this?
Yes, sir.
In some cases, remember beta, negative sign can also come here. Now I ask you, if this negative sign would have come, so there was a negative here, there was a negative here, there was a negative here. Then I would have asked you, now what? Does the acceleration decrease with time or does the acceleration increase with time?
Decreases with time.
No, still increases. Negative sign does not mean that it is decreasing. Do we understand this? Here, negative does not mean the negative of maths, where negative numbers are smaller than the positive number. Negative only indicates what? It only indicates the direction. Negative only indicates the direction, my dear friend. So that means if the acceleration is -5, it only indicates the direction of acceleration. If the acceleration is +3, it only indicates the direction of acceleration. Which acceleration is more, -5 or +3?
-5.
-5. You don't say minus because minus only indicates the direction. 5 is more than 3.
5 meter per second.
Do we understand this? Yes or no? No, yes.
Yes, sir.
So that is how you must understand this. This question, I hope you have noted down this question. Question number 1 is as homework for you. We will discuss it in the next class. That is how we are winding up today's class. What we have done today, we have seen the concept of acceleration, uniform, non-uniform, average, and instantaneous. We have also seen what acceleration can do. It can change the magnitude only. Tangential acceleration, it can change the direction only. Normal acceleration, it can do both. And we have done some very wonderful examples. One example is left for you. In the next class, we'll move ahead, do more questions on acceleration and move on to motion with uniform acceleration. Till that time, take care, have a good day, and God bless you all.
Thank
Bye-bye.
you, sir. Bye, sir.